Hi everybody, welcome to Video Notes Unit 5, Sections 5A and 5B. We're going to look at these two objectives, so balancing combustion reactions and drawing energy diagrams. And here's what you have to know to be able to do it. So combustion, all right, combustion, look at that. That stuff is burning, all right? So hydrocarbon fuels burn in oxygen to form carbon dioxide and water. Why do we care about carbon dioxide? It's because it's one of the greenhouse gases that you learned so much about already, okay? And you can see all of these forms of combustion are hydrocarbons burning. So in your cars, diesel and petrol fuel, methane, burning wood, that's all hydrocarbons burning. So a complete combustion reaction is when a hydrocarbon is reacting with oxygen and it produces carbon dioxide and water. So generically, some number of carbons, some number of hydrogens, and maybe some oxygens always react with oxygen to form carbon dioxide and water vapor. Okay, so that's a generic combustion. All right, so this is what we're going to see when we talk about complete combustion. So a chemical equation shows overall the process in a chemical reaction. So here's a formula, chemical formula, reacting with another chemical to produce new things, all right? And so notice this is the carbon right here. Here's a hydrogen, a hydrogen, a hydrogen, and a hydrogen. This is also known as methane, but it's CH4, it's this chemical formula. And so it has the mass ratio of carbon to hydrogen. It always is, or else it's not that compound. This is an element. How do I know it's an element? Because this is oxygen, and that's oxygen, that's oxygen, and that's oxygen. All the atoms are the same. They are bonded together. This is carbon dioxide because you get the carbon and two of the oxygens. And then this is water because you have two oxygens and total, and then four total hydrogens. Now, this is one molecule of H2O, okay? And this is another one, and this is CO2. And if it doesn't have that ratio and that mass ratio, it's not those things. So this is one example of a combustion reaction. All right, so what happens in a chemical reaction is it starts out as all reactants, and then these things hit each other and slam into each other. Remember how gases are in constant motion and hit each other? If they hit with enough energy, then the bonds of everything can break apart, and when they break apart, then they can rearrange to form this, okay? So before the reaction and then after, particles rearrange, atoms rearrange to make new substances. That's a chemical reaction, new substances. How do they rearrange? Well, you got to break the bonds in the reactants, okay? Break all those bonds so that they come together and make new bonds to make new things. So we have a H2O right there, a CO2 right there. This used to be, that was O2 and that was CH4. Okay, now if there's a carbon atom here, even if it's in a CH4, then you better be able to find that same carbon atom on the other side. It could be in a new compound. Okay, so chemical equations are equations that describe the reaction using element symbols and chemical formulas. The starting substances are called reactants. Reactants at the start, right? You start with reactants. The substances produced by the chemical reaction are products, and the arrow points to products. Finish, right? Arrow points to products. Arrow says to produce, points to products. Points to products in chemical reaction. Okay. All right. Here is a few more things to look at in a chemical reaction. So again, reactants on the left of the arrow, products after the arrow, arrow points to products, plus sign in between two different substances, all right? These numbers in front are called coefficients. If you don't see a number, you know it's a 1. And then the little numbers are called subscripts, and they give the chemical its identity, like O2 is this, all right? O2 is that. All right, next, here's another balanced equation, and it shows the chemical formulas, the particle pictures, and then the names of each thing. So this is C3H8. You can see the carbons in there. 1, 2, 3 carbons. All these are hydrogens. There's 8 of them, and it's one whole particle. And then 5 O2, so coefficient of 5 means 5 of those things. Coefficient of 3 means 1, 2, 3 of them, and they're all CO2s, 4 H2Os, and then heat and light, which sometimes we just write as energy. Okay. All right, this is a balanced chemical equation. You got particle pictures, you got formulas and symbols, and then you got words. Okay, another one. What the? Okay, and so when I say hydrocarbons, this compound has to have hydrogen and carbon in it. Notice this one has 4 hydrogens in it, and I'm sorry, 4 carbons and 10 hydrogens if you count them all. But then there's 2 of them, so 2, 1, 2. Okay, 13 O2s. What? Okay, now you should be able to find all of the O's on this side. So then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them of the O's come in the water, and then plus 10 more, 16 more, so you get 16 O's here and 10 O's there for a total of 26 O's total. All right, if you look here, you get 2 times 13 is 26 O total. All right, so that's one thing that in a balanced equation, if you have atoms over here, even though they're bonded differently, you better find them over there. Okay, so again, particle picture, reactants, products, formulas and symbols, reactants, products, coefficients tell you how many of each particle. So how do you balance an equation? Well, you have to be able to find those atoms. So the identity is aluminum and oxygen, and it makes aluminum oxide. Okay, so I like to list the substances that are involved. Aluminum and oxygen are involved. Okay, and I like to count. So on the reactant side, so I put R for reactants, P for products. On the aluminum side, I have 1 aluminum. On the product side, I have 2 aluminums. On the reactant side, I have 2 oxygen. On the product side, I have 3 oxygen. Okay, this is not balanced because I need to find the same number of things on both sides. All right, so let me see what I can do. Well, right now I have 1 aluminum, and I'll just do open circles, 2 oxygen. Over here, I have aluminum, oxygen, aluminum, oxygen, oxygen. Okay, so that's one of those. All right, so let me see. Well, if I have so many oxygen over here, I need at least, well, I don't know. I have so many aluminum over here. I'm going to say I need another aluminum. So I'm going to put a 2 right there. And so now, instead of 1 of these, I have 2 of these. Okay, so I changed that. Now aluminum is balanced on both sides. Now we need to make the oxygen balance. All right, so I need more aluminum as well. No, I don't. Aluminum is equal. So let me just put a 2 here so I could try to get the oxygen to balance. So there's 1. Now I made another one. So I'll draw that in. Now I have 2 of those. So let's see. So I have 1, 2, 3, 4 aluminum. Whoops, come back. It was 2. Oh, what happened? I gotta go back. I can't go back, son of a gun. All right, well, let me look at this one instead. Okay, so I start off by counting. I have 3, so this is my reactant side. Reactant side is my product side. I have 3 C's on this side, 8 H's, and 2 O's. 1 C, 2 H's, and 1, 2, 3 O's on the product side. Okay, so let's balance it by putting in coefficients. So I need to have 3 carbon dioxides, so I can get 3 carbons. So that changes my carbon to 3. And now I have 3 times 2 is 6, 7 oxygen. And so carbon's balanced, but hydrogen's not, and oxygen's not. So let's get that hydrogen to work. I have 8 on this side, but only 2 on this side. So I would put a 4 there. So that's 4 times 2 gives me 8 hydrogen. 4 here plus 3 times 2 is 6 is 10 oxygen over here. So I have to recount. Now to get 10 oxygen over here, I'll put a 5. 5 times 2 is 10. And now look, 3, 3, 8, 8, 10, 10. It's balanced by putting in those coefficients. Okay, so a coefficient is something that you put in front of the whole chemical because you need another particle of that. All right, but when you have another particle, so water, all right, here's water, and here's another water. So when I have two water particles, I have two O's and 1, 2, 3, 4, 2, 1, 2, 3, 4. 2 times 2 hydrogens per thing is 4 hydrogens. Okay, so we did this one already, but I'll do it again. So when I start in my reactants and products, here's what I have. So now I can use coefficients to get me, so I need 3 carbons to make it carbons, but I also need, that makes 6 oxygen plus 1 more is 7. Okay, now let's see, I need hydrogens. I have 8 on this side, I need 8 on that side, so I put a 4 in front of hydrogen. That's 4 times 2 is 8. All right, but now I have 4 oxygen plus 6 oxygen gives me 10 oxygen. And then I would put a 5 in front of there. 5 times 2 is 10 oxygen. Yay, balanced again. Okay, let's try another one. All right, so here's my reactants. Here's my products. Here's what I have involved, nitrogens and hydrogens. Okay, so to start with, I have 2 of those and 2 of those. Over here, I have 1 and 3. Now I need to make this balanced. All right, so let me get some more nitrogen over here. If I put a 2 there, that means that here's what one looks like. There's an N and 1, 2, 3 H's, right? Now if I have 2 of them, if I do this as an N, 1, 2, 3 H's, so now I have 2 N's, but now I have 6 H's. Or I could do 2 times 3. That's 1, 2, 3, 1, 2, 3. Now I got to go to this side, and I have 2 N's, so that's fine. All right. So let's say N was like this, right? Boom, boom, N2. That's what it was, all right? H is H2, right? So I have 2 of those, 2 of those. But I need 1, 2, 3, 4, 5, 6 of these. So if I put a 3 here, all right, 1, 2, 3, 4, 5, 6. Now I have 6 of these. And look, 2 N's, 6 H's, woohoo, balanced and happy. Boom, boom, balanced. Okay, let's look at a visual of that. So the N's are blue, 2 of them. Sorry, 1, 2, 3, 4. So 1, 2 N's on this side, 2 N's on that side. That's balanced if we use these coefficients. 2 H's. Let's see. On the left side, we have 4 H's. On the right side, we have 6. So it's heavier with this. But if I do another one and I do 3, boom, boom, all right, that'll put 2 more on this side, and that would even out to 6 and 6. Okay, so you don't have to show ones, but if you don't show one, you know it's a 1. Okay, so the balanced equation would be N2 plus 3H2 produces 2 NH3 particles. Yay! Okay, let's look at the next one. So that was about balancing equations. There's one other thing that goes on when reactions happen. Okay, so reactants are always on this side and products are on this side. And so what happens in a chemical reaction is you always have to come uphill first because you have to add energy because energy is going up here. You have to break bonds and add energy in. But then when new bonds form, it's a relief, and so energy comes out. Now, if overall more energy comes out of the reaction than went in to break the bonds, heat comes out, and it's called exothermic. All right, you might see light or see burning or feel heat. Okay, endo, so exo exit, heat comes out. So after the arrow is the heat's leaving. Okay, endo means in. All right, so that means heat is before the arrow. Okay, and so you can see you got reactants, you have to break the bonds. It takes a lot of energy to break them, and then once they're all broken, then they got to come back together. It's always a relief to come back together. So the products, you always go uphill first, break them, and then make them. But this time it didn't go downhill more than it went uphill. So heat has to be added in before the arrow. That's endothermic, heat added in. Okay, so exothermic, here's the energy diagram for it. So reactants are always higher than products and break bonds and then make bonds. And the leftover energy after that process happens, if energy is left going out, then in the chemical reaction, energy will be after the arrow, right? After the arrow, okay? Because it takes a little bit of energy to break these bonds, but then when these bonds form, a lot of energy is released, and so then there's extra energy left over. That's exothermic. Energy is released after the arrow. Okay, energy diagrams for endothermic, you got reactants, you got to break the bonds, break them, and then make them. Okay, So you're always releasing energy when new bonds form, but this time it takes more energy to break them than gets released when they form. So energy is added in. Energy added in as a reactant. Okay. All right. So here's something to help you remember. Energy diagrams in terms of bonds. All you have to remember is to barf. Gross, Harbin, barf. Yeah, barf. Okay, so what happens is wherever the reactants are, you always have to go uphill first to break bonds. Breaking bonds absorbs energy, okay? And then if you come downhill, you always release energy when new bonds form. Okay, so this is products. So this is endo because it takes more energy to break them than to make them. What's exo? Well, reactants, you always got to go uphill first. BA, get ready to barf. Breaking bonds absorbs energy. But this time, the energy that's released when new bonds form is more than it took to break them. So this is energy released is exiting. Okay. All right. Oh, barf when you do chemical reactions. All right. So make sure you can label the reactants and the products in an energy diagram. Okay. Energy of the reaction is the difference between reactants and products. So this difference, since it releases energy. This is exo released. All right, here we go. This is endo absorbed. Whoops, endo absorbed. All right, so let's keep on. Bond breaking absorbs. Always go uphill first, and then you finish the barf by releasing energy when new bonds form. Okay, so to review, combustion reactions burn hydrocarbons to make carbon dioxide, greenhouse gas. Chemical equations must be balanced. You have to know reactants, products, arrow coefficients, and chemical formulas in the chemical reaction. All right. Energy can be absorbed endo, product produced exo. Diagrams can show endo and exo, and where the energy is can show endo and exo. And